Callers, hola. The goal is to create a short video on factoring. Hopefully this will work, we shall see. This is just a continuation of today's class. Hopefully I can do a short videos of the different type of factorings. So we can move on in class and you can watch the video at your leisure. So for now, I'm going to focus first on the greatest common factor, GCF, greatest common factor. I'm going to do a couple of them step by step, and hopefully we'll get the agility to move on quicker. Always, folks, you can break this down. For example, if I want to factor 4x plus 12, we recognize that, of course, 4x can be broken down as 4 times x, 12, 4 times 3. Notice that, of course, we have 4 as a common factor, so we can quote unquote pull it out. So 4 parentheses, we leave behind the x and the 3 will be x plus 3. You should always verify going backwards, distributing 4 times x, 4x, 4 times 3, 12. Voila, done. It's as simple as that. So let's try this other one. I'm not going to break it down. I mean, not writing it down. 6 times a, 6 times 4, of course, 6 is the greatest factor, parenthesis a plus 4. And leave it up to you to multiply. I have the papers, otherwise I'm a lefty, so I'll be erasing what I just wrote. Here, notice 14 times x, 14 times 1. Of course, we can always factor out the 14, and then we have x plus 1. As I told you in class, folks, be careful with this one. Sometimes we forget to write it down, so we get stuck with the problems. Okay, this one is a bit more complicated. 2 times, let me just write it down, this one step by step. So how do I break this guy? This guy, 2 times 1, 2, 3 x's, 2 times x and 10x, plus 12. Can be, by the way, this is 12, 2 times 1. I forgot the 1. Just put it down. So it's 2 times 1. And then here would be 12, would be 2 times 6, and then 1, 2. 1x, 2x. So notice that, of course, we have as a greatest as a factor the 2, the x, and the x. So x times x, of course, is x squared. So this guy will be, I can pull out the 2. I can pull up 2 x's, so x times x squared. And what do we leave behind? 1 times x, that will be 1x plus 6. That's it, there is nothing else. So that would be it. We can always verify multiplying backwards. Okay. So here, let's see if we can do it mentally. As for sure, we can pull out the 2. Notice that all the numbers are even. So 2 times 10, 2 times 5, 2 times 7, and we should stop there because when I break down the 10, 2 times 5, the 5 is prime. 14, 2 times 7, 7 is prime. So there is nothing else we can factor out in terms of the numbers. So we can factor out the numbers. Notice that we have x cubed, x squared, x to the 1, which we never write the 1. Every time I'm looking for the greatest common factor, and then I have the variables, I always choose the variable with the lowest exponent. That would be x to the 1. I have x to the 3, x to the 2, x to the 1. So the lowest exponent will be x to the 1, which of course we never write it down. So let me repeat. When we're looking for the greatest common factor, and we have the common variable, we choose the variable with the lowest exponent. Later, we're going to be looking for the least common denominator. With the least common denominator, I choose the greatest exponent. For the greatest factor, I choose the lowest exponent. Right? So for the greatest factor, lowest exponent. For the lowest denominator, the greatest factor. Hopefully you got it. So let's see, continuing here. So parentheses, 20 divided by 2, that will be 10. X to the 3, that will be x squared. And 10 divided by 2 will be 5x, 2, 1, so we leave 1, plus 14, 2, so we leave behind the 7, and that's it. We are done. Okay. Okay, so let's continue here very quickly, folks. I have these lines. -6, -18. When the lead coefficient for the lead term here, this is the lead, this is the first one and the one with the highest exponent. If it's negative, always factor out the negative. Notice that here I can factor out either the 6, this is 6 times 1, 6 times 3, or the -6. If the lead term is negative, always factor the negative number. In this case, we'll factor -6. I repeat, we could have factored just the 6, pull out the negative as well. Why? Because the lead term is negative. So if I were to factor out the 6, I leave behind the x. Careful, this is minus, so that would be plus 3. So let's verify it. -6 times x, -6x. -6 times +3, -18. Okay. Let's look at this other one. This is, by the way, 21. 7, 21, 7 times 3. Notice that I can factor out the 7 or -7. Since my lead term is the negative, we factor out -7. Notice that I have a squared, a to the 1, so we can factor out 1a. So we leave behind only 1a here. This is plus, so now it becomes minus, -3. So let's verify it. -7a times a, -7a squared, -7 times -3, 7a, sorry, that will be positive 21a. Okay. Hopefully that will be a little bit clear. Notice, folks, that here I have 8n times n minus 4 plus 5 times n minus 4. All right, so n minus 4 can be factored out as just the binomial, so n minus 4. So what do I leave behind? 8n plus 5. Parentheses, 8n plus 5, voila, we are done. Okay, so let's go ahead and try another one. Let's go ahead now and try factoring trinomials. Trinomial, namely 3 terms of the form ax squared plus bx plus c. Let's get familiar with this all the time. Ax squared, a is the coefficient of the square. B is the middle term when x to the 1, and c is the number by itself, the constant. So ax squared plus bx plus c. So the first case is when a equals 1. Okay. If the trinomial factors, as I mentioned today, if the trinomial factors, it will factor as a multiplication of 2 binomials. If it factors, it will factor as a multiplication of 2 binomials. I'm going to assume that actually the first thing we need to do always attempt to factor the greatest common factor. So let's assume there is no other greatest common factor. So let's proceed to factor this trinomial. I always use a very boring example to make a point. So let's see if I have x squared plus 6x plus 8. Notice that a here is 1, B is 6, C is 8. Those are my ABCs. Always identify those. So I told you, folks, that this will factor as a multiplication of 2 binomials if it factors. So of course, x squared, so x here, x here. So now let's look at the combinations. Notice that C, my third term, is positive. If I have a positive number, how do I get a positive number? When I multiply. The 2 numbers are positive or the 2 numbers are negative. So the middle terms are going to be the same, either both positive or both negative. Let's look at this B, at this middle number, the number is positive. Okay, so I want everything to be positive. And now we look for factors of 8 that when I add them gives me 6. As I did in class, I'm going to do it on purpose wrong. I'm going to do this wrong. Factors of 8, 8 times 1, 4 times 2. Okay, so on purpose, I'm going to plug in 8 and 1. Let's see what happens. 8 and 1. And now we attempt to FOIL to distribute so that the O and the I, the inner and the outer, in the FOIL procedure, remember first, outer, inner, last. So the O and the I will be, when we add them, will give me the middle one. In other words, this times this, and this times that. So 8 times x, 8x. 1 times x, just x. Normally we don't write the 1. I'm going to write it on purpose. So we 1x, 8 plus 1, 9x, which is not 6. Okay, thanks, but no thanks. Adios, gracias. We don't, we like you, but you don't help us in this time. Okay, so we move on to the next numbers, the next combo, which will be 4 and 2. 4 and 2. 4 times x, 4x. 2 times x, 2x. 4 plus 2, voila, 6. Done. This one factors properly. What if I have x squared minus 9x plus 8? Okay, once again, multiplication of two binomials, x and x. 8 is positive, so the signs have to be the same. Since my goal is to get -9, well, maybe we want both negative. Factors of 8, that when we add them gives me 9. In the negative way, you get the drill. If I put the 4 and the 2, I will get -6x. That will not help. So let's go ahead and try the 8 and the 1. -8 times x, -8x. -1 times x, -1x. When I add -8 plus -1, voila, -9. So we factor this one properly. What about if I have x squared minus 2x minus 8? Now my 8 is negative, so the signs have to be different. One is plus, the other one is minus. And my goal, of course, is to get -2. Okay, so once again, on purpose, I'm going to use the wrong combination. So I remember, how do I get the 2? Well, if I use the 8 and the 1, that won't help me much because my goal is to get to -2. Okay, so the 4 and the 2 will be a great candidate. So I'm going to place the 4 here and the 2 here. Let's see what we get. 4 times x, positive 4x. -2 times x minus 2x. When I add 4 plus -2, 2x. Oh, and I want negative. Okay, so we're close. The only thing we need to do is either make this guy negative and this guy positive, or switch the numbers. So I'm going to switch the number just to be consistent, folks. So this will be plus and minus. So now I place here the 2, I place here the 4, and then we do the same thing. 2 plus x, positive 2x, -4 times x minus 4x. When I add, that will give me -2x. Voila, we are done. Penultimate example, what about if I have plus 7x minus 8? Okay. Notice that the sign is negative. That means that the signs have to be different, just like the previous example. Notice here, folks, that my b was -2. So between the two numbers, the 4 and the 2, since I wanted the negative, that means that the highest number, the 4, would carry the sign. So I get the negative number. Here, since I'm going for plus, factors of 8, that will give me 7. So the candidates will be 8 and 1. But since I want my 7 to be positive, we want the 8 to be the positive and the 1 to be the negative. So now we verify 8 times x, 8x, negative 1 times n, negative 1x, 8 minus 1, voila, 7. Yeah. So hopefully you're getting this. It's not that I'm boring as well, but I'm trying to use the same number because it's the same technique. I just don't want to confuse you. So I have x squared plus 11x minus 8. Okay. So now factors of 8, negative 8, that will give me positive 11. Okay. Notice that this is minus, so the signs have to be the same. I'm sorry, the signs have to be different. The first one positive, the other one negative, or vice versa, it doesn't matter. Combination that gives me 11, good luck. 8 minus 1 will be 7, 4 minus 2 will be 2. My goal is to get to positive 11, so we don't have those numbers. So what do we say? This puppy is prime or non-factorable. I prefer prime. I have issues pronouncing that word, as you noticed with my pronunciation. So anyway, so we can say that this trinomial will be prime, and that will do it. Okay, I believe this video is going to get a little bit longer. Sorry about that. I was trying to do it short. So now let's go ahead and try something very similar. Oops, see. Let's go ahead and attempt to factor trinomial for the form ax squared plus bx plus c. But this time a is not going to be 1. It's a number other than 1. Okay, so what I'm going to do, I'm going to use the method called the AC method. You might see it with another different names, AC methods. Remember, A, B, C. AC means A times C. So we are going to multiply A times C. So let's go ahead and do an example. I have 3x squared plus 22x plus 7. I think I chose one too simple. So anyway, so let's see what we have here. A is 3, B is 22, C is 7. So the first thing you're going to do, you're going to multiply A times C. So always multiply A times C. It's what is called the AC. 3 times 7, 21. And what is the middle number? 22. Okay, so this is A times C. Oh, okay, let me do this again. Sorry about that. So we are going to take A times C and we're going to move it to B. So 3 times 7, 21. What's the value of B? 22. Okay, so that's what we have. Now, the drill is the following. Times plus. I need to find two numbers. When I multiply, it gives me 21, and when I add them, it gives me 22. The same numbers, of course. Well, we know that 21 is 3 times 7, but 3 plus 7 will be 10, and my goal is to get 22, so that would not work. I also know that 21 is the same thing as 21 times 1, but also 21 plus 1 is 22. Voila, we are done. So what do? We know that 21 is the same thing as 21 times 1, and 22, 21 plus 1. By the way, folks, if you cannot find these numbers, then you may conclude that the trinomial is prime. That's all we are going to conclude. If I cannot find these pair of numbers, these two numbers, then the trinomial will be prime. So we just learned that, of course, 21 is 21 times 1, and 22, the B number, the middle number, can be broken down as what? As 21 plus 1. That's exactly what we're going to. We're going to rewrite the trinomial, but in this case, we're going to replace 22 by my lovely numbers here. So what do we say? This is the same thing as 3x squared. By the way, 21 is positive and the 1 is positive, of course. So that will be plus 21x plus, again, normally we don't write the 1x, we just say x, but just for
for showing purposes, I'm going to do 1x, and then of course plus 7. We have not done much. We just simply rewrote 22 as 21 plus 1. And now we can use factoring by grouping. What does it mean grouping? Divide and conquer. Take the first two and the second two and attempt to factor the greatest common factor. So let's look at this one. What is common in here? What can I factor out there? Well, I can factor the 3, because this is 3 times 1, 21 is 3 times 7, and also 1x. So I can factor out 3x, and what are we leaving behind? We're leaving behind 1x plus 7. You should always multiply back just to verify. And let's see what we can factor out here. 1x plus 7, there is nothing to factor except 1, because this is prime, there is nothing else to factor. So I'm going to factor out the 1. Once again, on purpose, I'm going to write the 1, don't be shy. I'd rather write this that it looks ugly than wrong. So let me just put the 1 here, and then just simply say x plus 7. And if you remember the last example of part A, that I did factor the whole binomial, we can apply the same concept here. Knowing that x plus 7 is common. Okay, so good. So let's go ahead and factor out x plus 7. So what do we leave behind? 3x plus 1. By the way, folks, even though it doesn't look pretty, this 1, this is why I like to factor the 1. Because sometimes if we don't write the 1, and when I factor the 3, the x plus 7, sometimes my students do this, x plus 7 times 3x, and they forget the 1. This is why I always write the 1. It's correct, it's not pretty, but it's correct. This is mathematically correct. Okay. Anyway, so let's try another problem, folks. I have 8x squared minus 14x plus 3. Okay, once again, let's identify A times C, A, B, C. A times C, 24. My middle number will be negative 14 times plus. What's the magic? Two numbers, and when I multiply gives me 24. When I add gives me negative 14. Okay, so this will be interesting. Remember that 24 is 8 times 3, 6 times 4. That doesn't help me to get to 14, but 12 times 2 gives me 14. So 12 times 2. However, I need both negative. Negative 12 times negative 2 will be plus 24. And then negative 12 plus negative 2 will be negative 14. So this is the case that we put both negative. So we repeat the process, 8x squared plus 3. And we say that the negative 14 can be written as minus 12 minus 2. And we just simply do grouping. These two, let's see what we have. 8, 12, 4 times 2, 4 times 3. So most likely we can factor out 4x. And we leave 2x minus 3. Here I have negative 2x plus 3. There is not much to factor. However, if you remember, I told you that if the lead term is negative, we may factor the negative. The only thing I can factor here will be negative 1. And again, I like to write the negative 1. I don't care if it doesn't look pretty, but it's correct. So the negative 1, you just simply change the sign. Minus 2x now becomes positive 2x. Positive 3 becomes minus 3. Oh, and guess what? These and these are the same, so we can go ahead and proceed to factor this puppy. What are we leaving behind? 4x minus 1. And voila, we are done. Okay, so hopefully you got it. The only thing I'm going to record after this will be 3 more examples.
If you get this, that's okay. You can stop the video now and watch for my next video that I'm going to be doing special cases of factoring. So I will attack perfect trinomials, which we did today. I'll attack difference of squares, which we did today, and perfect cubes, adding or subtracting of perfect cubes. And that will do it. So that will be the next video. Thank you. Okay, so let's go ahead. If you, this is just extras. If you want to continue, there are maybe 2 or maybe 3 examples. So let's see very quickly, folks. My goal is to do it in 2 minutes or 3 minutes or less. 8 times 5, negative 40, middle number, negative 3, times plus. Factors of minus 40, that gives me minus 3. And just, I know the numbers, I'm just giving you some time. Hopefully you came up with negative 8 times positive 5, almost the original numbers. Minus 8 times 5 would be negative 40. Minus 8 plus 5 would be negative 3. Okay, so that's it. So 8a squared minus 5. And what we're going to do, we're going to write negative 3 as minus 8a plus 5a. Okay. And now we proceed grouping. From here would be 8a parentheses a minus 1. And here we can factor out positive 5, a minus 1, a minus 1, parentheses 8a plus 5. Voila, we're done. Now, sometimes my students say, well, what happens if I write it the other way around? Okay, so let me take advantage of this example and let's go ahead and do something very similar. So let's say that we didn't do this. This is equals to what? 8a squared minus 5. Now I'm going to write plus 5a minus 8a. Instead of doing negative 8 plus 5, I did 5 minus 8. Same thing, commutative property of addition. So grouping, what do I have here? The only thing that I have here common would be 1a. So what do I leave behind? 8a plus 5. Negative 8a, negative 5. The only thing I can factor out would be negative 1 parentheses. I change the sign. Minus 8 now becomes positive 8a. Negative 5 becomes now plus 5. Guess what? 8a plus 5, 8a plus 5, oops. So I can factor this guy, so I leave a minus 1. Same answer as we had before. So it doesn't matter how you write it, you always get the same answer. Let's do one more. Okay, I have 6x squared plus 5n minus 4. Some time. 6 times negative 4 minus 24. Middle number positive 5. Very similar to the previous one I erased. Factors of negative 24, that gives me positive 5. So perhaps 8 times negative 3 is minus 24. And 8 plus negative 3 would be positive 5. In this case, since my middle term, my second number was positive, the higher number keeps the positive. In the previous example, b was negative, so between the 8 and the 5, the 8, which was the higher number, carried the sign, the negative sign, I should say. Okay, so 6x squared minus 4, what do I have here? 5 can be broken down as 8 plus negative 3. So plus 8x minus 3x minus 4. And now grouping. What do I have here? 3 times 2, 4 times 2. So of course we can factor out with 2x. That would be 3x
plus 4 minus 3x minus 4. The only thing that we can factor is a -1. Change sign, so 3x plus 4, and voila, 3x plus 4 times 2x minus 1. Okay, hopefully this was helpful. I'll attempt to post it later today or tonight. And I'm open for feedback. Tell me if that was helpful. At the minimum, I will do, as I told you, the perfect square trinomial, difference of squares, and perfect cubes. And then if you believe it's helpful just to do these little videos, then I'll can commit myself to record videos when I believe are appropriate and when I feel in the classroom that some of us will be were struggling a little bit. Okay, so we'll go from there. Thank you so much.